little broader for a second. What are some of the misconceptions about tap conductors, Gil?
Yeah, a lot of people feel that tap conductors don't have overload protection, but the overload protection may not be in the form of an overcurrent protective device ahead of that tap, but it's controlled by the load. You'll see the common denominator as we go through the tap rules, that the ampacity of the load cannot exceed the ampacity of the cable of the tap conductor.
Okay. And again, if we go to 240.4E and 240.2, we find the definition of tap conductor. So let's take a step even further. Let's go right back to what a tap conductor is, or what makes something a tap conductor.
A tap conductor is generally, it's generally smaller than the conductor that it's being fed from. And it, once again, the supply, the overcurrent protective device is not located at the supply. You mentioned 240.4E. Now, the 240.4 is where we find tap conductors rules that are not located within Article 240. For instance, motor controls, single motor taps will be found in 430.53. Appliance, household ranges, where taps are used. You'll find those requirements in 240.19. So there are other places where the tap rules exist.
So when you go to 240.2, I'm reading straight from the article, as used in this article, this is the definition of tap conductors. A tap conductor is defined as a conductor other than a service conductor that has overcurrent protection ahead of its point of supply that exceeds the value permitted for similar conductors that are protected as described elsewhere in 240.4, as you mentioned. So I think it's important to reinforce, again, what we're talking about with tap conductors here. Right?
Exactly. So when you look at that definition and you look at the that has overcurrent protection ahead of the point of supply, that overcurrent protection is protecting the feeder that the tap is coming from. So the rating of the ampacity rating of that feeder conductor is consistent with the overcurrent protective device ahead of that. What isn't consistent is the tap from that feeder. Now that conductor is going to be a lot smaller, or it's going to be smaller than the feeder conductor itself.
Let's move on to branch circuit tap conductors covered at 240.21A.
Right. This is a reference back to, I mentioned household ranges before. This is a reference back to 210.19 and 210.1920 that deals with how we determine the overcurrent protective device. And 210.20 gives us the requirement that says the load shall be calculated at continuous load and 125, non-continuous load and 125% of the continuous load. Okay. And 210.19 is the maximum load to be served.
Then there's feeder taps, 240.21B, under A, of course, talking about feeder taps instead of branch circuit tap conductors. What's important to note about feeder taps?
Feeder taps is actually the topic of our discussion today. 240.21 is subsections A, B, and C. C is the rules for taps from transformer secondary conductors. The rules for feeder taps are found in 240.21B.
Okay. Then we've got distances of the taps, right? That sort of, there's different categories for these. We've got not over 10 feet long, not over 25 feet long. What's important to note about the distinction of distances? Why? Why is it broken up by distinction of distances?
Right. Once again, because we don't have the overcurrent protection ahead of, at the supply, we need to control that load. We're looking at distances of 10 feet, 25 feet. We're looking at over 25 feet. We're looking also at the what I consider the manufactured building or the high-rise, high-bay building 100-foot tap. And then there's the unlimited tap as well. And each one of these has different criteria that needs to be met before you can apply that tap rule.